Yes, students. So now as we have seen that the attraction force of the earth towards any object is denoted as the small g, that is the acceleration due to gravity. Now because of this, because the motion is produced inside the any object, because it is pulling any object towards itself, so we can say that the motion is produced in any object, and that gives the new equations of motions. So here we are having different equations of motion for free falling objects. Mark my word, here we have just taken for the free falling objects, not for the objects that you are throwing at somebody. Then you have to take the same equations of motions that we have read in the chapter 2nd. Okay, so students, here we are having the old equations and the new equations. So you can know, you know that the first equation of motion is v is equals to u plus at, where v is the final velocity, u is the initial velocity, a is the acceleration. Okay, you know that, and the t is the time taken. Okay, so time and acceleration, everything here could be the same. In the new equation part, you know, now a is get to be replaced with this small g, because here the pulling thing is done by the earth and it is pulling every object towards itself, because they are not applying any force on any other thing, because they are just dropped. Okay, if any object just dropped, it is not applying any force on the environment, on the surrounding, and it is not even thrown by somebody with a certain force. Then how does it moving now? Because of this force. So this pulling force is now considered as the part of the acceleration, and that again is the value with the 9.8 meter per second square. Do you know that? We have just obtained this value with the calculation. And the second equation of motion is s is equals to ut plus half at square. Now this will replaced as the h is equals to ut plus half gt square. Now s is replaced with the h part. Why? Because students, you know that the earth is spherical in shape and everything here would be pulled towards the core of it, okay, towards the center of the earth. Now everything would be considered as the height, because for this center part, if you are taking this, like some object is here, so it will be like, if you are suggesting that we can say, yes, this is the distance, you can even measure it in the part. So distance and the height could be measured into standard unit, that is the meter only. Okay, so it doesn't even कोई फर्क नहीं पड़ता है, that you can write here s also, but because हम जब भी core की बात करते हैं, then we have to take कि कोई height पे है कोई object, because earth का core नीचे है, that is in the down part, and something falling from the above, तो हम उसको height ही मानते हैं. That is why we have taken here as h. h is equals to ut plus half gt square. And the third equation of motion is v square is equals to u square plus 2as. So again, this would be the part as the v square is equals to u square plus 2gs, and g here again a. Okay, so a is replaced as the g. So students, here are some postulates that are related to the freely falling of the body, and that would be considered, because when you are going to solve questions, then these parts would be taken as the main part, like आपको ये ध्यान में रख करके ही question solve करने हैं. Fine. So here is the first question is that if body falling downwards, if the body is falling in the downward direction, then G would be taken as the positive. Okay, so U would be taken as the 0. Like I have told you the example that when you are dropping any ball from the building, so that ball is falling towards here, towards the ground, and here because it is dropped first, then the U will be equals to 0, and that G will be is equals to as the positive term, because it is falling towards the gravity and gravity is the only thing that is pulling it. Okay, now the second thing is if the body is thrown upward, then u would be some value. Like if you are throwing a ball in the upward direction, okay, now the ball is going in the upward direction but the initial velocity was not 0 in this case, it is some value. Okay, that some value now will give it the reason to move in the upward direction, but because it is going against the gravity, now it is moving against the gravity pull. Okay, so here in this case we will take it as g minus. So minus 9.8 meter per second would be the value for the g here. Okay, now the third thing is time of ascent is equals to time of descent. If a ball is moving here in the downward and it is moving in the upward, the time taken by these two will be equivalent. Okay, we will not consider here any positive or negative term, but the time for these two cases would be taken as the equal.